Hello everyone, welcome back to my channel InfoSec Lab. Today we're going to talk about XXE injection, one of the most common vulnerabilities in web applications. In this section, we'll explain what XML External Entity injection is, describe some common examples, explain how to find and exploit various kinds of XXE injection, and summarize how to prevent such attacks from the threat actors. Okay, so introduction. XXE, which is known as XML External Entity Injection, is a type of security flaw that exploits vulnerabilities in web applications' XML input. It occurs when an application accepts XML input that includes external entity references within the XML itself. Attackers can leverage this vulnerability to disclose local files, make server-side requests, or execute remote code. Given the widespread of the use in XML web applications, particularly in web services and SOAP-based APIs, the severities of these vulnerabilities cannot be underestimated. Exploring XML. So what is XML? XML stands for Extensible Markup Language, which is a markup language derived from HTML, Standard Generalized Markup Language, which is the same standard as HTML is based on. XML is typically used by applications to store and transport data in a format that's both human-readable and machine-parsable. It's a flexible and widely used format for exchanging data between different systems and applications. XML consists of elements, attributes, and character data, which are used to represent data in a structured and organized way. XML syntax and structure. XML elements are represented by tags, which are surrounded by angle brackets. Tags usually comes in pair, with the opening tag preceding with the content and a closing tag following with the content. For example, user, name, age, address. These are the tags. This one is the opening tag and this one is closing tag. As you may notice, every opening tag comes with the closing tag. The tag name John represents an element name, but the content is John. Attributes provide additional information about the elements and are specified with the opening tag. The tag user ID 1 specify an attribute ID with the value 1 for the element user. Character data refers to the contents within the elements, such as John. The example above shows a simple XML document with elements, attributes, and character data. The tag XML version 1.0 over here at the top of the document. Declaration indicates an XML version, and the element contains various sub-elements and attributes representing the user data. The tag XML version 1.0. The tag XML version 1.0 declaration indicates the XML version, and the element contains various sub-elements and attributes representing the user data. Some common use cases in web application. XML is widely used in web applications for data exchange, storage, and configuration. It's often used for web services and APIs, such as SOAP and REST, to exchange data between systems. XML is also used for configuration files, such as web server configurations or application settings. So what is XSLT? XSLT stands for Extensible Style Sheet Language Transformations. It's a language used to transform and format XML documents. While XSLT is primarily used for data transformation and formatting, it is also significantly relevant to the XXE XML External Entity attacks. XSLT can be used to facilitate XXE attacks in several ways. Data extraction. XSLT can be used to extract sensitive information from an XML document, which can then be used in an XXE attack. For example, an XSLT style sheet can extract user credentials or other sensitive information from an XML file. Entity expansion. XSLT can expand entities defined in an XML document, including external entities. This can allow an attacker to inject malicious entities, leading to an XXE vulnerability. Data manipulation. XSLT can manipulate data in an XML document, potentially allowing an attacker to inject malicious data in or modify existing data to exploit an XXE vulnerability. Blind XXE. XSLT can be used to perform blind XXE attacks, in which an attacker injects malicious entities without seeing the server's response. What are DTDs? DTDs stand for document type definitions, define the structures and constraints of an XML document. They specify the allowed elements, attributes, and relationships between them. DTDs can be internal within the XML documents or external in a separate file. Purpose and the usage of the DTDs. Validation. DTDs validate the structure of XML to ensure that it meets specific criteria before processing, which is crucial in environments where data integrity is key. Entity declaration. DTDs define the entities that Entity declaration. DTDs define entities that can be used throughout the XML documents, including external entities which are key to XXE attacks. Internal DTDs are specified using the doc type declaration, while external DTDs are referred as using the system keyword. So every time we see a doc type declaration right here, we know that DTD is internal, whereas if we see something like the system, right here, it doesn't show anything. But when you see system right here, it refers to the external DTD. Okay, the example above shows an internal DTD defining the structure of a configuration file. The element declaration specifies the allowed elements and their relationships. So a config database, username and password. DTD and XXE. DTDs plays a crucial role in XXE injection, as they can be used to declare external entities. External entities can reference external files or URLs, which can lead to malicious data or code injection. XML entities. XML entities are placeholders for data or code that can be expanded within the XML documents. There are 5 types of entities: internal entities, external entities, parameter entities, general entities, and character entities. So here's an example of external entities. We have the XML declaration, we have entity, and over here, as we can see, we have a system, which refers to external entity. This shows an external entity reference to a URL. External variable reference within the XML. Reference within the XML document will be expanded to the contents of the reference of URL. Types of entities. Internal entities are essentially variables used within an XML document to define and substitute contents that may be repeated multiple times. They are defined in the DTD and can simplify the management of repetitive information. So for example, we have doc file right here, we have entity, internal entity. Remember, wherever we have an internal entity, we have a declaration of doc type. Entity information, this is a test. Just think of it as a variable in a programming language where you can refer to its values. In this example, the variable if entity is replaced by its value wherever it appears in the documents. External entities are similar to internal entities, but their contents are referenced from outside of the XML document, such as from a separate file or URL. This feature can be exploited in XXE. In XXE attacks, if the XML processor is configured to resolve external entities. So in this example, the entity extension refers to an external URL right here. Parameter entities are special types of entities used within the DTDs to define reusable structures or to include the external DTD subsets. They are particularly useful for modularizing DTDs and for maintaining large-scale XML applications. For example, we have right here, we have entities, common C data. In this case, the common variable is used within the DTD to define the type of data that the name element should contain. Okay. General entities are similar to variables and can be declared either internally or externally. They are used to define substitution that can be used within the body of the XML document. Unlike parameter entities, general entities are intended for use of the document contents. For example, we have this one, the entity author. is a general entity used. The entity author is a general entity used to substitute the author's name wherever it's referenced in the document. Okay. So it's similar to the internal entities. Character entities are used to represent special or reserved characters that cannot be used directly within the XML documents. These entities prevent the parser from misinterpreting XML. These entities prevent the parser from misinterpreting. These entities prevent the parser from misinterpreting XML syntax. For example, we have %LT for less than symbol, %GT for the greater symbol, and then % is for the %. Yes. Of course. This usage ensures that the special characters are processed. This usage ensures that the special characters are processed correctly by the XML parser without breaking the document structure. The image below shows type of entities in the DOM structure. Okay, we have the entity, then we have the general entities, we'll have the parameter entity. Within the general entities, we have character entity, we have the mixed content entity, and we have the unparsed entities. So in the unparsed entities, we have the entities that contains the content cannot be parsed, such as sounds, graphic, or non-character data. So based on this diagram, we see that there are a lot more subcategories of XML entities. We're not going to dive deep into this because that's not going to be the priority of this topic. Okay, this image below shows the type of entities that are in the DOM structure. Okay, hold on a second. The image below shows the type of entities in a DOM structure. Entity. So within entity is the top of the domain, top of the tree, and then within the entity we have the general entity, and we also have the parameter entity, which is the syntax. The syntax start with a percent sign. The general entity the syntax start with the percent sign. It's right here. And then within the general entity, we have character entity, we have the mixed content entity, we also have the unparsed, which contains the contents that can be parsed, like sounds, graphics, or non-character. So when you take a look at this one, we know that there are a lot more to cover when it comes to XML entities, but we're not going to dive deep into that, as it's not going to be our major priority today. Let's move on. What is the meaning of the HTML, Standard Generalized Markup Language? Okay. What is the meaning of the acronym DTD? Document types definition. XML parsing mechanisms. XML parsing. XML parsing is a process by which an XML file is read. This information is accessed and manipulated by software programs. XML parsers convert data from XML format into a structure that a program can use, like a DOM tree. Using this process, parsers may validate XML data against a schema or a DTD, ensuring the structure conforms to certain rules. XML parser. XML is a XML parser. XML parsing mechanisms. XML parsing is a process by which an XML file is read, and its information is accessed and manipulated by a software program. XML parsers convert data from XML format into a structure that a program can use, like a DOM tree. During this process, parsers may validate XML data against a schema or a DTD, ensuring the structure conforms to certain rules. If a parser is configured to process external entities, it can lead to unauthorized access to the files, internal system, or external websites. Some common XML parsers. Several XML parsers are used across different programming environments. Each parser may handle XML data differently, which can affect vulnerability to XXE injection. DOM parser. DOM stands for Document Object Model. This method builds the entire XML document into a memory-based tree structure, allowing random access to all parts of the document. It is resource-intensive but very flexible. SAX parser. SAX stands for Simple API for XML. Parses XML data sequentially without loading the whole document into the memory, making it suitable for large XML files. However, it is less flexible for accessing XML data randomly. STAX, which stands for Streaming API for XML parser. Similar to SAX, STAX parses XML documents into a streaming fashion, but gives the programmer more control over the XML parsing process. XPath parser parses an XML document based on the expressions, and is used extensively in conjunction with XL. XPath parser parses an XML document based on expressions and is used extensively in conjunction with XSLT. What XML parser builds the entire XML document into a memory-based tree structure? Answer the questions below. What XML parser builds the entire XML document into a memory-based tree structure? That's DOM. What? DOM parser. Similar to SQL injection, XXE also has in-band and out-of-band injections. For in-band XXE, it refers to the vulnerability where the attacker can see the response from the server. This allows for straightforward data exfiltration and exploitation. The attacker can simply send a malicious XML payload to the application, and the server will respond with the extracted data or the results of the attack. Out-of-band XXE, on the other hand, refers to an XXE vulnerability where the attacker cannot see a response from the server. This requires using alternative channels, such as DNS or HTTP request, to exfiltrate the data. To extract the data, the attacker must grab a malicious XML payload that will trigger an out-of-band request, like DNS query or an HTTP request. So let's first take a look at the in-band XXE. We have to go to this contact form on the application, fill out the form, and then capture the request. Let's do it first. Okay. Oh no. The submitted data is processed by the contact_submit PHP. Right here, we see the URL, which contains a vulnerable PHP code designed to return the value of the name parameter when the user submits a message in the form. So after we submitting the message, it's going to return the user on the front end. Echo thank you. So in this case, once we submit the message, we'll see thank you, haha, your message has been submitted. Since the application returns the value of the name parameter, we can inject an entity that's pointing to the ACID password file to disclose its values. This is going to be the payload. Alright, so we see the content of the ACID password file. Using the payload above, replacing the initial XML data structure submitted, and send a request. Okay. XML entity expansion. XML entity expansion is a technique often used in XXE attacks that involves defining entities within an XML document, which the XML parser then expands. Attacker can abuse this feature by creating a recursive or excessively large entities, leading to a denial of service. Defining external entities and reference sensitive information. This method is central to both in-band and out-of-band XXE, as it allows attacker to inject malicious entities into the XML data. So for example, if we take a look at this one, we see that the name is displayed twice. So when you send this request, it's going to display the name twice. This is a test, this is a test. This is just a demonstration of the concept. In real world, attackers are trying to use this XML file to exhaust the resources on their applications. Here's the explanation. In the payload above, XXE is expanded wherever it happens. Attackers can use the entity expansion to perform a build and lapse attack, where a small XML document recursively expands to consume server resources, leading to a denial of attacks. What is the XXE vulnerability occurs when the server's response is immediately disclosed to the attacker without the use of external channels. That's in-band XXE. What is the content of the file here in the OPT directory? So we run this. We just have to modify our payload a little bit here. And we send it. PT. And we get a flag right here. Alright, exploiting out-of-band XXE. On the other hand, to demonstrate this vulnerability, let's go to the home page right here. The application uses the code below when a user uploads a file. Alright. The code above doesn't return the value of the submitted XML data, hence the term out-of-band, since the exfiltrated data has to be captured using an attacker control server. Let's go. Now first, drop on the interception, and we'll go back to the home page. In this attack, we will need a server that will receive data from the servers. You can use Python http.server module, although there are options out there like the Apache or Nginx. Using the attack box, we spawn a Python web server using this command, upload the file in the application, and monitor the request that is sent to the submit.php using the bubs. Forward the request to the bub repeater, and using the application payload to replace the value of XML file. Okay, let's try that. First, let's try oh no, forgot to intercept. Sorry. Okay, we have the submit.php right here. Send that to repeater. And replace the payload, the data. This one we modify with our attack box IP address, which is 10.10.32.196. However, Python 3.m http.server 137. Now we send it. So it looks like there's a connection to the server. After sending the modified HTTP request, Python server will receive a connection from the target machine. The establishment of the connection with the server indicates that the sensitive information can be extracted from the application. So by knowing that the server connects back to our HTTP server, we know that we can actually extract the target machine information and then send those information back to our server. We can now create a DTD file that contains an external entity with a PHP filter to exfiltrate it from a target application. Save the same DTD file below and name it sample.dtd. Then the payload below will exfiltrate the contents of the SC password and send the response back to the attacker controllers. So this is how you perform an outbound SSD. First, let's cancel the server. Now we have to upload. Wait. Now I have to modify this one. 10, not 10, 32, 196. Now run the server. So we drop everything. Forward. Oh, we have to expose the SC password file. It is. Nothing connects. Let's take a look at the IP address is correct. Let's see what I did wrong here. So this is the explanation of this DTD. It begins with a declaration of an entity or a command that points to a system resource. The command entity refers to a resource within the PHP filter protocol. This is PHP. This one, it retrieves the content of SC password, a standard file in Unix-based system containing user account information. The convert-based SysDefault encode filters encode the content of the base SysDefault format to avoid formatting problems. And the outbound XXE entity contains another XML entity declaration, exfil. Okay. Here. Which has a system identifier pointing to the attacker control server. It includes a parameter name with a CMD representing a base 64 encoded content of the SC password file. When the outbound XXE entity is parsed, it creates an exfiltration entity that connects to attacker server. Okay, the parameter data equals CMD sends the base 64 encoded content from the CMD. Go back to repeater and change your payload to we don't upload this file. We don't. So everything so far is correct. We upload the system right here. Upload the file. So that's what I did wrong. Copy. This is annoying. Can't paste it. Right here. There we go. Now the attacker IP address is going to be 10.10.32.196. Let's double check. Never hurts. Yeah, 10.10.32.196. Simple DTD. Send it. P file not found. The file not found. We send a request, check the terminal, you receive 2 requests. First one requests a sample DTD file, and the second is a request sent by the vulnerable application containing the encoded SC file. So we have file not found here. Something's wrong. Let's see what I did wrong here. So we save this one as the sample DTD. Let's try one more time. Start over. Sample.dtd. Paste the content. Not yet. We have to modify. Ten dot 10.32.196. Okay. Now we try to upload the file. Let's try it again. Drop everything. Okay, it doesn't, so I guess it doesn't really matter what we upload because we're going to modify the payload anyway. This is upload.php. No, we're not interested in this one. We're interested in this one. Send this one to repeater. Over here, we replace the payload. Upload the system HTTP sample DTD. Over here, 10.10.32.196. And I have to make sure that I have the HTTP server up running. 1337. Okay, cool. Sample.dtd. Send it. And there we go. Got everything. Copy, we go to subchef to decode it. And we got the content of the SC password file. Cool. So this is how we exploit an out-of-band XXE. What kind of an XXE vulnerability occurs when the response of the server is not visible to attacker out of band? SSRF and XXE. Server-side request forgery attacks occur when attacker abuses functionality on the server, causing the server to make requests to unintended location. In the context of XXE, an attacker can manipulate XML input to make the server issue requests to internal services or access internal files. This technique can be used to scan the internal network, accessing restricted endpoints, or interact with services that are only accessible to the server's local network. Internal network scanning. Consider a scenario where a vulnerable server hosts another application internally on a non-standard port. An attacker can exploit an XXE vulnerability that makes the server send requests to its own internal network resource. For example, using the capture request from the in-band XXE tags. Send the capture request to the web intruder and use the following payload. Okay, so we go back to the content.php page. Intercept off. Let's go to tag.php. This one. Does it really matter? Now we paste this payload in here. Before we proceed, let's take a look at what it does. Send it to intruder. Okay. External entity is set to fetch data from the local host and then the port number 10 right here. In this case, intruder will send a redirect the request and search for internal services on the server. So now we have to brute force to enumerate the port number. Send this one to intruder. You can right click and send to intruder or Control I or Command I. Watch it. Over here, we have at the position of payload and number from 1 to 65,355. Is it the total number? 65,535. We have XXE. $65,535. Okay. Everything looks good. Let's start attack. So we're going to take a look at the length size difference. Okay, while we wait for the attack to complete, let's continue reading. So far this is what we've done. We send a request to intruder, set up the payload and the position, and perform the brute force attack to discover the port number running internally in the server side. So how the server processes this? The entity XXE is referenced with the name tag, triggering the server to make an HTTP request to specify URL when the XML is parsed. The response of the requested resources will then be included in the server response. If an application contains secret keys, API keys, or hard-coded passwords, this information can be used in another form of attack, such as password reuse. Potential security implications. Reconnaissance. Attackers can discover services running on internal network port and get insights into the server internal architecture. Data leakage. If the internal service returns sensitive information, it could be exposed externally through the errors or XML data output. Elevation of privilege. Accessing internal services could lead to further exploits, potentially escalating an attack's capabilities within the network. What is a flag in the application running internally? Okay, what port is the internal application hosted on? So let's see, have we found the port? Looks like we haven't found one. Okay, let's get to the mitigation. Let's get to the mitigation step, and then we can come back to the attack. Avoiding misconfigurations. Misconfiguration in XML parser settings are a common cause of XXE-related vulnerabilities. Adjusting these settings can significantly reduce the risk of XXE attack. Below are details of guidelines and best practices for several popular programming languages and frameworks. General best practices. Disable external entities and DTDs. As a best practice, disable the processing of external entities and DTDs in your XML parser. Most XXE vulnerabilities arise from malicious DTDs. Use less complex data formats. Where possible, consider using simpler data formats like JSONs, which do not allow specifications of external entities. Allowing listing. Input validation. Allow listing input validation. Validate all incoming data against a strict schemas. Validate all incoming data against a strict Validate all incoming data against a strict schema that defines expected data types and patterns. Exclude or escape XML-specific characters such as greater size, smaller size, and single quote and double quotation code. These characters are crucial in XML syntax and can lead to injection attacks if misused. Mitigation and technique in popular languages. In Java, we use document builder factory and disable DTDs. In .NET, we configure the XML readers to ignore the DTDs and external entities. In PHP, we disable loading external entities by libxml. In Python, we use diffuse XML library, which is designed to mitigate XML vulnerability. Regularly update and patch. Software updates. Keep all XML processors and libraries go up to date. Vendors frequently patch known vulnerabilities. Security patches. Regularly apply security patches to web applications and the environment. Security awareness and code reviews. Conduct code reviews. Regularly review code for security vulnerabilities, especially code that handles XML input and parsing. Promote security training. Ensure developers are aware of secure coding practices, including the risks associated with XML parsing. Right. So that's how you prevent XXE vulnerability in web applications. Let's go back to our brute force attack. Okay, we got one. Port 81. So this is the flag and this is the port number. Cool. So I noticed I didn't answer the questions in this one. Exploit the in-band XXE. What did I miss? Okay, in-band XXE. Yep. Conclusion. XXE, XML External Entities attacks arise from improper handling of user supply input in web applications, particularly in XML parsing. Attackers exploit vulnerability XML processors to inject malicious external entities, leading to data exfiltration, server compromise, or denial of service. XXE vulnerabilities can be prevented by disabling external entity expansion, validating user input, and using secure XML parsing libraries. Additionally, implementing security best practices such as input validation, output encoding, and secure coding practices can significantly reduce the risk of XXE attacks. Regular security audits, code reviews, and training on secure development practices are essentials for identifying and mitigating XXE vulnerabilities. By understanding the risks and taking proactive measures, developers and administrators can protect their applications from XXE attacks and ensure security and integrity of the system. The recap of the concepts. So far, we concepts the basic understanding of XML, XML Parsing Mechanism. We also learned about two main types of XXE injection, in-band and out-band. We also learned how to combine XXE injection with the server-side request forgery to perform reconnaissance on the target internal services. And last but not least, we talk about some mitigations, some of the best practices when it comes to secure coding a web application in order to prevent XXE injection attacks. And that's it for the room today. It's pretty simple and basics. I hope you have fun with this room. And if you have any questions, feel free to reach out to me. Thank you very much, and I'll see you next time. Bye.